Hello everyone, we will continue our lesson. For now, we already in chapter 17. We will learn about higher derivatives and application. For 17.1, what we will discuss is the topic about maximum and minimum points. Let's get started. So, our learning outcomes. After this session, you will be able to use the first derivative to identify stationary points of curves, and then use the first derivative to determine the stationary point's nature. Okay, before we discuss about stationary points and nature identification, let's look this example. So we have a quadratic curve, and the equation is y equal 3x squared minus 6x plus 1 for x greater than 0. We will find dy dx, and then we will find the coordinates of the point at which dy dx equal 0. So from the 3x squared minus 6x plus 1, dy dx will be 6x minus 6. Is that correct? Yeah, and we can have 6 taken out, becomes 6 in bracket x minus 1. And for dy dx equals 0, we can make this value equal 0 so that x is 1. So when x equals 1, we can calculate y. Y is 3 times 1 squared minus 6 times 1 plus 1. From this equation, we substitute x equals 1 and we got the value of y. In here, y is minus 2. Then, the coordinates are 1, minus 2. This is the coordinate where dy dx equals 0. The point 1, minus 2 at which dy dx equals 0 is known as stationary points. But do you know why is it called stationary point? Okay, let's see this explanation. From this diagram, we can see that this is the quadratic curve, and the point 1, minus 2 will be the point of the vertex. For the vertex point, we already saw that the curve seems to stop at that point for a while. That's why it is called the stationary point. Moreover, there are 3 types of stationary point nature that will be discussed later: how to define maximum, minimum, and inflection. And you may already recognize that the nature of stationary point 1, minus 2 is minimum. Why? Because you can see as x increasing from left to right, the value of y is decrease and then increase. Let's see example 1. Given a curve equation y equal x cubed minus 6x squared plus 9x plus 2. Find dy dx, and then find the stationary points. For the first one, let's rewrite the function and have the derivative. So x cubed become 3x squared, minus 6x squared become minus 12x, and 9x become 9. In here, we can factorize, become 3x minus 1, x minus 3. And let's see for the stationary point. We already know that the stationary point is when the dy dx equal 0. So that in here, we have 2 values that satisfy 3x minus 1 times x minus 3 equals 0. That is, x equals 1. And we can calculate y. Where we can calculate y? We can substitute 1 to this y equals, yeah? In this first equation of y, you substitute x equals 1 and you got the value of y is 6. And we have the second value of x. When x equals 3, you can also substitute. Now you substitute it with 3 and you got the value y is 2. So you can see that the coordinates of stationary points, we have 2 points. The first one is 1, 6 and 3, 2 respectively. Let's compare with the graph. In here, the graph will be like this. It is a cubic equation, and we can see that for this graph, the first point here is 1,6 and 3,2 is here. You can see that both of them are vertex point. How to define the 2 points nature, later we will discuss that. Example 2. Show that the curve y equal 3 minus 2 over x for x greater than 0 has no stationary point. So let's rewrite. This is the function, and we will have the dy dx. So 3 is gone, so that we have minus 2 over x become 2 over x squared. For x greater than 0, we can see that 2 over x squared will be always positive. Whatever you put x, the value of x squared will be a positive number, so 2 over x squared will be always positive. So the gradient of dy dx of the curve will be always positive. It means the curve will be always increasing, and we have no value of dy dx that is equal 0. Hence, we can conclude that the curve has no stationary point. Let's see the graph. The graph will be like this. The visualization of the graph, it will be increasing always, and it has no stationary point. Okay, let's continue to the next example. We back to example 1 and see this graph. This cubic equation, now we want to define the nature. What is the nature? Whether it is a maximum or a minimum or maybe inflection. Here, we can see that 1,6 from the graph is maximum point. Why it is a maximum point? Because as x increasing from left to right through 1, y is increasing and then decreasing. So you can also notice that this is a point of maximum compared to its neighbor. This is also called the stationary point of maximum. For this 3,2, this is a minimum point. As you can see from left to right, through x equals 3, the y value is decrease and then increase. So, we can conclude the first one, stationary point achieved when dy dx equals 0. The second one, there will be 3 types of stationary points nature. The first one, a stationary point of maximum when increasing y happen and then decreasing y. Minimum of stationary point happen when the y value is decreasing and then increasing. And the point of inflection, later we will continue the example for discuss about this. It is happen when y keep increasing or decreasing. So that's all for today. We will continue the lesson at the next meeting. See you again, guys. Have a good time in studying. God bless you all, and bye-bye.